the thing here is we want to combine the bottom two equations in such a way that they will form the first equation. We can modify, well, not really change, but just write differently either of the bottom two equations by, one, flipping the equation, reversing it so that the products become the reactants, or multiplying the entire equation by any number. Let's look at this first equation. It has a P4 on the reactant side. So does the equation we want to create. So not only is the P4 on the right side, well, not the right side, the correct side. It's on the left side. But also there's the right number of P4, because there's one up here, there's also one here. So I'm pretty happy with the way this equation looks right now. I'm not going to change it. Okay, let's look at the second equation. Something that we still need to get in our top equation is PCl3. PCl3 was not in equation 1, so it's going to have to come from equation 2. So here PCl3 is on the left side, the reactant side, but it needs to be on the product side, on the right side. So what we have to do is flip the second equation. The product becomes the reactant, and the reactants become the products. But the most important thing here is that we also have to flip the sign of the enthalpy change of this reaction. So if it was an exothermic negative enthalpy change, it now has to be positive. And we need 4 PCl3, as you may have noticed. So that's okay. We can get 4 by doing the second kind of modification, which is to multiply the entire equation by 4, including delta H. All the coefficients that were 1 now become 4. And the change in enthalpy is 4 times 123. So it is 4 times greater, but still positive. So I think we've gotten to the point where we want to try adding together the first equation and our modified equation 2. And hopefully it'll work out. So I'm going to get rid of the old equation 2's and just leave our new modified version. Now I'm going to move it up here so it will be easy to add these equations together. First, I'm going to correct my little typo. This was for PCl3. And crap, I'm going to correct my other typo. This was Cl2. Okay, so I have fixed the typos, copied our modified second equation. Now let's add up the first and second equations. We have P4 on the reactant side, and we're going to have 4 PCl5, but I can look over here on the product side and see that we can cancel out 4 PCl5 from the reactant side with one on the product side. This is similar to what we did with net ionic equations. So if something appears as the same on the reactant side and the product side, we don't have to put it in our overall equation. And we don't want it in our overall equation because PCl5 does not appear in the equation we're trying to make. We're also going to want to end up with 6 chlorines. So since we have 10 chlorines here on the reactant side, hopefully we'll be able to cancel 4 of them on the product side. Oh, here they are. That's exactly what we were hoping for. So we can cancel 4 chlorines on the product side with 4 chlorines on the reactant side, which leaves us the 6 that we need. And I will put them down here for the overall equation that we are trying to produce. So that's everything on the reactant side. And the only thing left on the product side is 4PCl3. I don't think I made any more typos because this is now the same as the reaction in question. And that is good. To get our answer, we just add up the enthalpies. And that is the answer we were looking for.
Made with Doodlecast Pro.